Welcome back to the deep dive. If you feel like you need a full-time staffer just to keep up with AI news right now, you are definitely not alone.
No, not at all.
The pace has gone from, dizzying to just truly overwhelming.
Right.
So our mission today is to cut through all that noise. We want to give you the absolute necessary shortcut to understanding the direction and, crucially, the velocity of AI development.
And that velocity is the perfect word for it. When we distilled all your source material, three massive overarching trends just jumped right out.
Okay.
And these themes are, they're fundamentally reshaping the landscape. First, you have this radical expansion of open source models. They're now competing directly on efficiency and cost, not just, on size.
Let's rank the second.
The second is the definitive shift from static LLMs to fully autonomous agents. These things are designed to handle complex multi-step tasks.
And the third?
And third, well, the major legal and ethical pushback. It's finally catching up, fueled by these multi-billion-dollar lawsuits.
Okay, let's unpack all of this. We're going to start at the core with the models and the intense competitive heat they are generating.
The open source movement and the multimodal breakthrough.
Exactly. Then we'll pivot to the tooling and autonomy that enable these agents. And finally, we'll tackle the massive real-world stakes, enterprise adoption, safety, and those huge legal battles.
Let's dive right into the model race, because the very definition of winning has completely changed.
How so?
It's no longer about who has the biggest parameter count. The defining feature right now is all about efficient performance.
Right. And combined with this new willingness for big players to open source models that genuinely rival the giant.
Exactly. And this is where the strategy gets really interesting. You're seeing these smaller, specialized companies strategically weaponize efficiency.
You mean like Arcee AI?
Perfect example. They just released Trinity Nano and Mini. These are sparse mixture of experts or MOE models.
And for you, the listener, MOE just means the models are massive, but only a tiny fraction of their network is actually active for any given query. It's a very clever way to scale.
And the numbers are just staggering. They trade them on 10 trillion tokens.
10 trillion.
And then release them under the permissive Apache 2.0 license. So the key insight here is that they're highly effective with only about 3 billion active parameters per token.
So it's not just a research paper. This is them trying to define a new standard for cost-effective AI.
It's an aggressive calculated bet on scale through sparsity. And they're already teasing a Trinity Large for 2026 with 420 experts.
And this competitive pressure, it's absolutely global. At the same time, you've got this huge challenge coming from the East.
Right. The Chinese startup DeepSeek, they launched V3.2 and V3.2 Speciale.
With some really big claims, too, near GPT-5 or Gemini 3 Pro performance.
But, and this is critical, at a significantly lower inference cost.
That's the move.
It is. What's fascinating is the strategy. Their 685 billion parameter model was released under the MIT license.
One of the most permissive out there.
So this isn't just about showing off. It's about accelerating their market presence by, just letting people use it for free.
And their models are posting meta-level results on elite math and programming contests. So this isn't catch-up anymore.
Not at all. They are directly challenging the supremacy of Google and OpenAI in core reasoning.
And the race, it's not just about text anymore, is it? Multimodal is reaching serious commercial maturity.
We are way beyond simple image generation at this point.
You have Runway's Gen-4.5, which they're calling Whisper Thunder.
And it's climbing the text-to-video leaderboards very, very quickly.
We are also seeing this move toward unified engines.
Right, like Kling-01. It debuted as a single unified engine that can handle text, images, and video all seamlessly.
That seems like a foundational step towards a more generalized AI that understands context across different media.
It is. And we're already seeing companies like OpenAI using that exact technology for really sophisticated video-to-video editing.
The push for specialized multimodal AI is huge for regulated industries, too. I'm thinking of NVIDIA here.
With Alpamayo-R1.
Yeah, their open-source reasoning vision language model built specifically for driverless cars.
The need there is just immense. Autonomous vehicles, they don't just need to see an object.
No, they need what we would call common sense.
Exactly. If a model sees a bicycle leaning against a stop sign, it needs to reason that the bicycle is stationary, that it's not about to dart into traffic.
And Alpamayo-R1 is aiming to bridge that gap between just processing data and having human-like judgment.
So the head-to-head showdown couldn't be hotter. We've seen Alphabet's Gemini 3 surpassing OpenAI's ChatGPT 5 in some key academic and reasoning benchmarks.
But again, that international competition is fierce and is becoming very specialized.
It really is. I mean, look at ByteDance. They aren't just dabbling in LLMs. They debuted Vidi2.
Which is a multimodal AI video editor.
Right, and it can automatically process hours of footage to create polished, platform-optimized TikTok content.
That is a very clear move to cement their dominance in short-form video.
It is.
But it raises a good question. Is that truly cutting-edge, generalized AI, or is it more like highly specialized feature engineering for a very specific business need? How should you, the listener, differentiate those two?
That's the critical lens we all need to apply. Vidi2 is a business breakthrough. It's leveraging advanced techniques for a very specific, very profitable outcome.
Okay.
But the DeepSeek and Gemini models, they're pushing the general reasoning frontier. So it shows how the global market is fragmenting. Some are chasing AGI, others are chasing immediate dominance in very specific niches.
That's a great way to put it. And if we connect this to the bigger picture, the reason these models are becoming so functional and specialized is the explosive growth in the underlying tooling.
Absolutely.
We are definitely moving out of the era of pure academic research and into production-ready autonomous systems.
The foundational shifts are just massive. Let's talk about the developer core for a second. Hugging Face released Transformers V5.
Which they called their biggest overhaul in years.
And it is. They exploded their architecture support from around 20 models to over 400.
400! Wow.
That is a foundational seismic shift. It's rapidly accelerating what developers can even build on.
And the frameworks for building the agents themselves are seeing these really necessary functional upgrades.
Like LangChain 1.1.
Which is a staple for so many developers. It added things like live capability detection and a voice harness.
And that voice harness is incredibly practical.
It really is. It lets you switch between different providers, OpenAI, Assembly AI, 11 Labs, with literally one click.
It just democratizes access to advanced voice features. And we're also seeing engineering solutions that tackle the infrastructure bottleneck.
Right, tools like Unsloth introducing tiled MLP.
And the key takeaway there is just efficiency. This tool demonstrated fine-tuning with context lengths over 500,000 tokens.
While offering huge VRAM savings. And VRAM, for those of you unfamiliar, is the memory on your graphics card.
Which means developers can now do cutting-edge, long-sequence training on consumer-grade, or at least far cheaper, hardware. It massively lowers the barrier to entry.
Of course, the major players are getting into the framework game, too.
You've got Google's Agent Development Kit, which is a modular framework optimized for their Gemini models.
They're trying to make it as easy as possible to build on top of their engine.
And then OpenPTC Agent is advancing the sophistication. It's adding features like multi-LLM support and background subagents.
So they're constantly looking for tools or info that the main agent might need.
Precisely. This is moving way beyond the simple single-prompt chatbot. This is genuine orchestration.
And we are seeing real-world demos of autonomy that prove this tooling is working. The capabilities are just soaring.
One of the most compelling was Anthropic's Opus agent.
Right. We saw it working autonomously for a full hour to fix a complex unit test in Ray.
And that signals rising software engineering, or SWE autonomy. Think about what that means.
I mean, an agent was given a complicated problem in a messy existing code base.
And it methodically debugged, tested, and fixed it. All without human intervention for 60 minutes.
And when that kind of autonomous reasoning is paired with a precise execution engine like Opus 4.5 with NanoBanana.
The combined workflows are just showing these major leaps in design and engineering productivity.
Well, hang on a minute. We've been burned by early demos before. We saw the hype cycle around AutoGPT last year.
That's a fair point.
How reliable are these agents proving to be in messy, real-world conditions? Are they solving novel problems or just following pre-canned paths?
That brings up a critical, very technical discussion. The consensus among some top developers is that many current multi-agent systems still falter.
And why is that?
Because their internal structure is often too rigid, too static. If the task changes, the agent organization just can't adapt.
So they're arguing we need adaptive structures.
Desperately. And concepts like parallel thinking, which you see in frameworks like Threadweaver.
By adaptive structures, you mean the agents can dynamically reassign roles or change their communication protocol mid-task?
Precisely that. If they don't have that flexibility, the agents just hit a wall on novel, hard reasoning problems.
So the complexity of the goals is outpacing their internal design.
Right. If we want true autonomy, the agents need to be organizational designers themselves.
That is a huge shift in thinking. So what does this explosion of smarter models and more capable agents mean for people in the trenches? We've covered the tech.
Now for the immediate deployment in the real world.
Specifically, let's look at regulative industries.
The rapid adoption in sectors like finance and healthcare shows how fast enterprises are moving. These are not proof-of-concept projects anymore.
No, you have OpenAI and Accenture forging a massive alliance.
Right, specifically to deploy ChatGPT Enterprise to thousands of consultants, accelerating transformation across a huge range of industries.
And the finance sector is going all in. HSBC formed a multi-year partnership with Mistral AI.
And this isn't for customer service chatbots. This is to enhance core global banking operations.
Including critical, highly regulated functions like anti-money laundering checks. The industry is really betting trust on these models.
But we absolutely have to highlight the sheer financial cost of this speed.
This is a big one.
OpenAI's aggressive expansion has had a massive ripple effect, saddling its business partners, the big infrastructure providers like Oracle and SoftBank.
With how much?
With nearly $100 billion in collective debt to support the build-out.
$100 billion. Let's just pause on that number.
It's staggering.
That figure underlines the scale of this computational build-out, but it implies something crucial. The financial infrastructure for this whole revolution is being built on massive leverage.
It is.
That debt burden will inevitably dictate future pricing, partnerships, and market access for everyone, from startups to consumers. This isn't just a technical race.
No, it's a massive capital expenditure war.
Yeah.
And it's happening everywhere. The adoption isn't just in finance. In healthcare, the FDA itself is implementing advanced agentic AI tools.
To streamline their own regulatory operations?
Right, and Stanford University is taking this so seriously that they're making AI training mandatory for all future doctors.
Okay, so that's the official adoption, but there's a huge governance gap brewing just beneath the surface.
The shadow AI.
Exactly. A majority of radiologists are now reporting they're using unapproved shadow AI tools for tasks like report drafting.
Which raises huge privacy and oversight concerns. If an unauthorized AI is processing sensitive medical data, who is responsible if it hallucinates a finding or leaks patient records?
It creates a massive liability sinkhole.
And beyond industry, you see governments integrating this tech. The EU is considering AI-powered surveillance in drones for its Frontex border security overhaul.
Which raises immediate civil liberty questions, and the cyber risk is accelerating. A recent security report alleged the first large-scale, state-backed cyber espionage openness was run entirely by AI agents.
Using Claude code, the threats themselves are becoming autonomous.
Which forces governments and corporations to grapple with security risks that operate at machine speed.
Okay, so now let's pivot to the legal consequences. Because if adoption is rapid, the legal firestorms are immediate.
Especially over data and privacy.
The data and copyright battles are intensifying into what could be an existential crisis for the models themselves.
We're talking about a coalition of 9 major U.S. newspapers suing OpenAI and Microsoft.
For over $10 billion.
$10 billion.
And that lawsuit is aimed squarely at the foundation of how these models are built. They allege the AI was trained on unlicensed news articles.
And crucially, that the models reproduce that content verbatim when prompted.
If the plaintiffs win, the entire paradigm of scrape and train it fundamentally changes overnight.
Privacy is another enormous flashpoint. Google is facing a class action lawsuit.
Alleging that their Gemini AI features monitor private communications on services like Gmail and chat without user consent.
This is about crossing that boundary between helpful automation and active data surveillance.
And adding to that concern is the commercialization push. OpenAI is poised to introduce ads into ChatGPT.
Starting with the Android beta.
Right, and this sparks understandable anxiety about how that might erode user privacy, especially given how sensitive the conversations people have with AI can be.
The profit motive is now directly encountering the trust boundary.
And the risk isn't just in the application, it's in the operating system itself. The president of Signal gave a really severe warning about this.
Meredith Whittaker, yeah.
She cautioned that integrating AI agents directly into operating systems could endanger the privacy of messaging apps like Signal and WhatsApp.
Citing the massive, unrestricted access to personal data these OS-level agents require to function. They become the ultimate surveillance tool.
And finally, we have to talk about accountability and safety in the starkest terms.
A Texas family sued OpenAI, alleging that its chatbot, ChatGPT, contributed to a young man's suicide.
And that case is fueling an urgent, painful debate over AI accountability, over establishing legal liability and implementing the necessary mental health safeguards.
Safeguards these powerful conversational systems absolutely must have.
And on the technical safety side, new research shows that AI safety filters are still structurally vulnerable.
How so?
Researchers found models struggle to detect harmful requests when they're written creatively, as metaphors, poems, or with fragmented syntax. They're calling them creative prompt attacks.
So if a malicious actor is creative enough with their prompt, they can just bypass the guardrails.
That's the flaw. And tying all this back to that massive infrastructure debt, you have companies like NVIDIA urging the entire industry to embrace radical efficiency.
To curb AI's rising energy footprint.
Yeah, and the energy comparison is pretty compelling. A few seconds of high-resolution video streaming can rival the energy consumption of a single large language model prompt.
Wow.
So the environmental sustainability of this rapid leveraged growth is an increasingly serious long-term constraint.
What an absolute whirlwind. But hopefully this is giving you the necessary clarity. We've seen the speed of open source and multimodal innovation pushing the limits.
The rapid, debt-fueled adoption of true agent technology across the enterprise.
And the immediate multi-billion-dollar legal consequences in privacy and copyright.
The main takeaway for you, the listener, is this. The environment is shifting weekly, sometimes daily. You have to apply critical thinking.
When you're evaluating new models and tools.
Right. Don't just look at performance benchmarks. Examine the license, the governance structure around the data, and the implied cost. All of those factors influence a model's safety and its longevity.
So here's something for you to mull over that ties together several threats we discussed today.
Okay.
Early results from the Openness Index suggested there's currently a negative correlation between a model's openness and its leading-edge performance. So if maximizing peak performance currently requires less transparency.
And we know the performance comes with that staggering infrastructure cost, that $100 billion in partner debt.
How will the industry ensure that the most powerful, cutting-edge AI remains accessible, safe, and governed by principles the public can actually inspect?
It's a tension between performance, profit, and public trust that really defines this moment.
It's something to keep in mind as you watch the next generation of models drop.